Okay. So, hi. So, hello. What does your startup do?
Hey Tony, my name is Gural. I'm a founder of RapidReview. We help AI researchers automate their research process.
Like, what are the type of customers of your startup?
So our first target is AI research startups. So it's startups with lean teams who have one or two scientists who really need to scale up their operations and research.
So Anthropic and OpenAI, they have hundreds of billions of dollars now. How does a small AI research startup succeed, and how does your startup help those startups succeed?
That's the point, right? So the research space is an infinite frontier. There's so many problems to solve, and there's room for every small team out there. And every team in the new age of AI agents needs an operations platform to really do many experiments in parallel to improve their models.
How big of a frontier is it? Has OpenAI and Anthropic figured it out, or is there a lot more open questions?
Actually, that's the brilliant part about research. The more you figure out something new, the more opportunities you unlock for follow-up research. And so I don't think that the frontier of AI science will be closed anytime soon.
Well, like how differently could a AI research startup do it differently than OpenAI or Anthropic?
So it still is a human game where the human scientist needs to have brilliant ideas and hunch and intuition about what will work, what tricks will improve models. Every day we see those improvements happening across many fronts, whether it's world models, understanding physics, whether it's traditional LLMs, where it's compaction and different applications. So yeah, just having smart people who can come up with crazy ideas.
So how does your startup help those AI research startups?
Thank you. So the whole game for us is to minimize the feedback loop of when you get an idea for your research direction from when you to when you get feedback on that idea. And we orchestrate, agents doing the work of executing on your research ideas, and we make sure that those agents don't screw up along the way. The agents are forced to follow the research process of designing each experiment, reviewing it adversarially, doing the whole process, and then reporting back on their findings. This way you can try different trajectories at the same time so that you are not bottlenecked by the process of actually executing the model training and all that stuff.
And what's the output of like the tool? Is it like a research paper?
Sure. Actually, no. The research paper itself is not an output. The output for us is all the trajectories and learning that happens while the experiments are running. So when you, as a scientist, give your agent directions on what opportunities and what ideas to pursue, those all get logged and you get to see the trajectory of what worked and what did not work so that you can come up with better ideas in the future. At the same
Mhm.
time, the agents will improve your models, like along those different paths of ideas. Agents will iteratively work on things like hyperparameter tuning or different architectures for models in order to make them better. So good chances are you'll get a better model. But what you're guaranteed to get is all the learnings of, hey, what ideas have worked on improving the model and what has not worked.
Gotcha. And that, like how big of a market is it? Like how many like potential customers are there? How big are the different contract sizes?
Yes, so this is definitely one of the most exciting fields that exists today, at least in my personal opinion, because you have, as we talked about, so many opportunities in research to like really address that it's never the problem that there isn't enough problems, but there's always not enough people trying to solve them. And we have bottlenecks in the research space. Compute is definitely one of them. For now, we don't handle that. You have to bring your own compute, or like we'll give you compute, but based on credit systems. We use Lambda Labs as our compute provider by default. So you need compute, you need smart people, and then you need actually the ability to implement all your ideas. We help with the implement all your ideas part, but you still need to bring your smart people and compute. So because of those constraints, the market is still somewhat limited, but we see a growing number of people pursue machine learning research in universities. It's now one of the hottest
Mhm.
topics to learn. So we see a lot more smart people coming, and we also see a lot more compute being available.
Gotcha. That makes sense. And then like in the future, do you see like in like 10, 20 years, do you think there will be a lot more AI research companies or does like after the research is more better understood, there'll be fewer of them over time?
This is an interesting question, and you're one of the sub questions I think that involves is the scale of operations that is required to actually hit and be able to solve those problems. Compute, as we talked about, is one of those bottlenecks that, hey, it could be a limiting factor to who can enter the space in order to
Mm.
solve some problems. But we are seeing significant number of entrants in the market of compute where competition is actually growing, which is super exciting. We have AMD, Intel developing, Samsung even developing their chips, all of the big cloud providers developing their own chips. So I actually see compute and data center efficiency being improved over time, allowing for more entrants. And if you
Even
have,
more.
yes, and if you have people with crazy ideas doing like incredible things, there will always be opportunities for new researchers out there.
Gotcha. Is like a good analogy like the biotech industry where you have like a lot more CROs now, so then you can have a lot more biotech startups as a result? What's a good analogy for the industry? Like what the industry will look like?
I think this, given the fact that there's so many, parameters that are always changing and at play in this specific sector, there is there. It's hard to definitively predict something. But what we are definitely seeing is that we are seeing proof of the fact that different architectures, different learning methods, and different, the whole thing about world models, the whole thing about diffusion models, they do bring their own benefits, meaning that there is differentiation in the market of research. And I think that part about at the core of things, AI is just learning mechanism. How do we learn about the world or a specific task? And we are seeing that there isn't yet a single way of doing things. And because of that, we do not see the reason for things to collapse just yet. But at
Hmm.
the same time, the market is hard to predict. You're definitely seeing like Anthropic and OpenAI building those self-improving models, and that's really beneficial for them. But it is also unlocking this whole self-improvement angle for models to everybody else. That's kind of what we're also helping with is how do you take something that already works? How do you keep improving it autonomously over time? So it's a thing where they're helping themselves, but at the same time, competition from open source space is also enabling everyone else to do a lot more research and be a lot more productive.
Well,
So,
what does a AI research company look like? Like, what's the org chart for it like? Is it like one CEO, no salespeople, like 10 researchers? Like, what's the org chart like?
so the way I see AI research companies currently form and be successful is when they find a niche of research where they say, okay, we were going to hyper focus on this improvement. And there's typically more than one researcher doing this. There's two to three sometimes, and they really focus. They sometimes have decade of experience. Sometimes they're young and they're fresh and they have a hunch. And then once they have some traction, they raise some money. Traction being like the fact that they have the credentials to do something like this, and they get some technical results. They raise some funds in order to get the sales team in order to then hit the market with a solution. I do think that the whole hitting the market with an AI solution is still something that startups are having to evolve and figure out better because traditional business models of SaaS models, etc., are being eradicated. So that is something that's quite hot right now is to figure out how do you actually monetize something that provides value, but how
Mhm.
do you find the right way of marketing and selling it?
How do those researchers like in that company, how would they use your software?
So the software it's going to be open source. So that's the thing that I'm proud of the most is the fact that it will be open source, and it
Mhm.
is actually open source now, but we're tweaking and polishing things obviously. And we also have some people here at Cornell Tech using this. So the early feedback is pretty strong. The way this works is it plugs into Claude Code, Codex, Cursor, or OpenHands, any agent platform that you might use, and it converts that agent into a machine learning researcher. So it's a plugin that tells the agent what to do, how to operate, where to log, and make sure that the agent's work is reviewed by other agents so that agents don't cheat on research, because that's what we commonly see. LLMs will often take the path of least resistance, but our system is built in a way to adversarially check for that and make
Mhm.
sure that research happens as research should and not skewing the metrics. So yes, to answer your question, if you have Cloud Code, you just install a plugin and it works. We will ship, there's a UI where you can see all the paths and experiments done, and the Cloud Code plugin, it will essentially make sure that the agent does the job right. Same
Mhm.
with Codex, Cursor, etc.
Like those researchers, they have their own experimental, they can set up their own experimental setups as well. Like what about the problem is technically hard that to makes it that they want to use your solution rather than building their own?
Brilliant, brilliant question. And that's a conversation I had just 2 hours ago with a researcher here at Cornell Tech. They're building time series models. So they have their own setup, but it would have taken them days, if not weeks, to vibe code a solution similar in order to really be able to execute those experiments iteratively. Now, just being able to say that, hey, there's a solution that already does this and it works, made them so much more excited about just adopting it and giving feedback on how to improve it. So our path is to make it customizable and flexible. And because it's open source, you can actually fork it, tune it to your own needs. That's what we hope you will do. At the same time, so yeah, it is just the best practice setup that just works out of the box. If you want, you can tune it to your own needs, and we will make it customizable so that you can actually make it work for your needs the best. At the
Mhm.
same time, we're going to offer a hosted version where we'll add some compute credits for you. Again, Lambda Labs is supporting our work here. So we'll give you compute and we'll give you, an easier way to host things on just a website that we will provide. But if you don't want that, you can always use the open source version fully.
I'm trying to think of the experimental setup. We You have the hypothesis, and then you have two arms, and then you have the analysis afterwards, and then conclusion. Like, does it help? Is that structure like the same for all AI research? Where like how different is one AI research experiment compared to another AI research experiment?
So, brilliant question, and that hits the nature of customization, where researchers will be responsible for still making this product their own and work for them. One thing that is true to pretty much any experiment is the fact that you need to plan it. The plan needs to make sure that it's testing the right things in the right way. And once you're done with the experiment, you need to write up a report with numbers, with figures, with visuals to understand what exactly happened through here and the fact that you stay true to the plan. So those are the building blocks that we use. Mind if I show you a quick visual of this?
Oh yeah, sure. Go ahead.
So we're going to go quickly into our GitHub profile, and this is what we're talking about. Each experiment gets a plan that gets adversarially reviewed, and then you get a report that is also adversarially reviewed. If something is wrong, you have to redo the experiment. That's what it looks like here. It's when you go to an experiment, you get things like the plan, the report of what happened, and you get the plan of how it was supposed to happen. Now, that's one thing that happens when you do one experiment, but when you do many experiments, you need to learn from what you've done so far. And that's what we have the reflections for. It forces agents to work on analyzing what has happened. We force agents to take different perspective on things to understand what worked, what did not work, what kind of crazy ideas have we not tried. We try to introduce entropy into the research process here. And then we let you or the agent also come up with different other lenses on how to analyze the work so far. And all of those get reviewed and merged into signal synthesis, which is essentially how it is a macro level perspective on, hey, let's say you've done a bunch of experiments. Now you want to say, hey, now what? Where do we go from here? What kind of other experiments do we build? So this is also, it helps make sure that the research stays true on track instead of optimizing for the local minima.
So it runs a lot of different experiments.
Yes, that's the point, is
Oh,
because you can
interesting.
run experiments in parallel. This is what agents enable you to do is you don't have to be the one actually doing and implementing each experiment. But if you want your agents to implement the experiments, then you need a reliable, solution that makes sure each experiment is properly logged and each experiment actually does what it's meant to do. That's what we provide. Now your agents can actually scale up horizontally and do 5 experiments, maybe 10 experiments at a time. The more agents you join, the more experiments they can run in parallel.
Hmm.
And all of these experiments will then get reviewed together in order to make sure that the learnings are synchronized. That's the benefit. That's how research is done. It's a balance of exploitation and exploration. You need to try different things and then you need to learn from them. And that's what the project is set up for.
Gotcha. Is is like in optimization, there's like Monte Carlo where you try a bunch of different things and you hope that one of
Mhm.
the things that fits is the right answer. Like is this like that kind of thing where you're trying many different ways, or is there more of like a more like take a stab at it in one direction versus many
Great
different
question.
stabs?
So, and this is the thing that what's the current era of AI systems and agents, enable us to do. They enable real reasoning. So you don't have to just statistically try different things in order that's the algorithmic way of doing hyperparameter tuning, for example. But instead, you would use agents in order to reason over the different paths taken, in order to understand what kind of signal exists in your work so far. Like, instead of blindly trying the different sets of hyperparameters, you will probably do small studies to set up baselines about, hey, what kind of signal can we get from the smallest model in order to test on that and do some tuning on the smaller version before we go to the bigger version later on.
Hmm.
And you're probably going to do, hey, I'm not going to try all the different versions of this parameter. Instead, I'm going to try a good balance of different parameters and things like that. And the brilliant part is we just talked about only hyperparameter tuning. In reality, the reasoning capabilities of LLMs enable us to not only work on hyperparameter level, but also on architecture level, on data level. You can have different data engineering done in order to test to see what kind of learning order makes a better improvement for your model. Maybe the order matters, maybe the features matter, etc. So those are all the things that agents can actually do for you because it's just coding at the end of the day. And what we help with is we just help that, hey, all of those different attempts that research agents will take, they're all properly logged, and
Hmm.
researcher agents will properly be able to analyze all of that information over time. And
Gotcha.
same to you as the human. You get the visibility into that process. You get things like ML flow integrations. And actually, um, let's take a quick look into some of our bigger projects where it's auto research style projects with about 50 experiments and claims. So there you will get to understand, um, the different performances of all of the small experiments that are happening from like a quantitative perspective, for example,
Hmm.
in addition to getting to know like the logic and the reasoning that the agents took to get there.
Gotcha. A lot of the like research, like it doesn't like it might be like scientifically interesting, like it might satisfy like a curiosity, but it's like
Mhm.
more basic research. It doesn't have an end result. Like is this does this only work if there's like a tangible like
Quantitative
result that you're
measure.
trying to get? It's
Yeah,
result.
yep. We had to like think about this. We had to be like, hey, how much do we want this to be tailored towards open-ended research, perhaps, where there is no strict evaluation criteria, and that's actually the difference of this versus in a fully auto research style project that Carpathy introduced earlier this year, and there's other companies doing auto research improvements where it's agents just improving one specific metric over time. Instead of that, this does allow for more open-ended research, meaning that different trajectories and logic paths are analyzed and synthesized over time. Um, that said, at the current stage, it does work best when there is a number to really be the ground truth of how well something works. Because for more theoretical research or more like exploratory research into things like, hey, how do people think differently about things? Yes, you can do this, but you would really benefit when you can use agents in a very specifically like reliable evaluation system. So right now we're seeing that it works best for models, but future iterations will hit open-ended research as well.
And how expandable is this? Like if you hook this up to a robot that can pipette as well with its own like a little biology pipetting system, is it able to do biology research as well? Like how similar is this research to all the other research?
Let, Great question. Let me zoom out for a sec to answer this. So what we provide is just a system that says, hey, your research agents are following the right practices of doing experiments and that they learn from their mistakes over time. How the actual experiment is done and what the tools used for each experiment is up to you to decide. So it is you would typically already have a project that has, either where you can integrate things like robot tools if you want to. You would probably integrate your robot tools through programmatic access to robots, and you would give your own agents access to those tools. We do not provide them. We
Hmm.
provide the layer of, hey, you do the experiment right, and you learn from your work. That's what we do.
Gotcha. Interesting.
We
So
also
right now,
provide sandboxes. Sorry.
right now
Sandboxes is
there's like
just
the
GPUs. Mhm.
there's like the human judgment comes in like the funding layer like is this research interesting enough to fund a grant with,
Mhm.
and then the research the human judgment also comes in at the scientific review like journal layer where they're like reading your paper before they publish in a journal. There's also like the professor who has like judgment on like this is interesting enough for my PhD students to work on. Like how does the judgment of your software compare to the judgment of those groups?
I think the things you talked about is really comes down to taste, down to intuition, and how people have built their own understanding of research, and that's super important. That's what makes us as humans unique, and that's why we will be the ones creating those ideas that are seeds for agents to go and work on. What this system really is meant for is making the agents that are doing the experiments follow the right path of doing the experiment. So it makes sure that everything is logged. It makes sure that everything is reviewed according to the plan. And it makes sure that, everything that was supposed to be done during the experiment, the agent didn't cheat, it didn't report something wrong, it didn't come up with something, that the work is done properly. So it is more a verification for, hey, not whether this was supposed to be done in the grand scheme of things, whether this helps the world, for example, from funding perspective, etc., but it just makes sure that, hey, this experiment really proves this claim. Or, hey, this experiment was done in a robust manner where things that were supposed to be tested were actually tested. It is still the human who will decide the topic of research. It is still the human who will decide, hey, what large level uh, problem is addressed.
That makes sense. In physics, the best experimentalists, they understand the theory behind it as well. So a lot of
Mhm.
times they have the intuition already on what the results of the experiment would be before they even do the experiment.
Mhm.
Like how much of the theory goes into the experimental setup that you have?
Perfect question. So that's also something that we've heard from early users of this, and that's why like LLMs, they will come with baked-in theories. So your Claude agent will already have some predetermined knowledge about the space of science. That said, what we do ship also is we ship an integration to our literature review platform. Literature review platform is synced with Archive, so any machine learning papers on Archive are available there. So we introduce that literature review tool into the agents doing your experiments. So and we see people be creative with this also. We see people tell the agents, hey, before every experiment, you have to do a lit review. Or we see and like find relevant papers to gain that intuition. Or we see people do like literature review once every 3 experiments. So we just bring those scientific papers into the context window of the agent who's going to do the experiment.
So intuition would drive like with the experiment, but the experiment can also drive intuition backwards as well, where like
Exactly. You learn from outside knowledge as well as the knowledge that you created while doing the experiments. Bingo.
gotcha. Huh, interesting. So there's like a so the big models these days, they read in all the public information now. It's like
Mhm.
all ingested already. So now it's like limited by the amount of information available. So it's like the next goal for those to like learn information on its own, do experiments by itself. So is your like the forefront of that?
That's a perfect thing to explore, right? Because you're right that one of the real reasons why this was created is when you start reading research papers, like in many fields, but specifically in machine learning, you see the path of success. You see what worked and what led to that. You don't see all the trial and error that was happening, the 50 experiments that were before the 51st that worked out. So that data is not available. That is oftentimes only kept by scientists themselves, and it's not organized either. This is a solution for that. It's keeping track of every experiment, making sure it's replicable and reproducible, and that you can actually learn from that experience. So, say you've done this project on this field and you want to do another project in a field related to it, you can learn from not just other papers published on arXiv and other publishing spaces, but also from your past experience. That's the brilliant thing about, current LLM state of the world, that we can really learn from past experience. You just need to make sure that your experience is properly logged and kept and is of high quality, that you have something to learn from. Frequently, as humans, we will run experiments, but we will not log anything. We will not write reports about what this was for and what this was testing. That's what humans are bad at, is making everything, writing every report, writing every reasoning step. But agents, when they're forced to do that, which is what we do, we force them to write everything out. Agents will do that. And therefore, you will have a track record of exactly what was attempted, why it was attempted, what was the high level idea there, and why it worked or why it didn't work. So next time you can do better.
Gotcha. That makes
And this
sense.
is actually something that can improve the world also. You were right that this is the frontier where the data is not that available. So when you start running, I'm looking forward to a world where actually scientists start running these projects in the open completely. We're going to try something like that. We're going to try efforts where multiple research projects are running in parallel online, fully open, so scientists can, show the work of agents trying all these experiments live so that humanity can learn from this, but also agents can learn from each other so that the research happens better next time.
That makes sense.
Yeah,
It's like a it's like a very like complicated machine, like the Formula One car. You have a machine, but you have a steering wheel, you have gas pedals still. Like, what are the levers that the human have to influence where the computers go? Like to provide the human taste to it.
great. So one of the most critical questions that you have to solve for when doing this kind of semi-autonomous research is you need the scientists to still be able to understand what it is that the agents are doing, at least on a high level, and if they need to, on a specific level. And this is this is like one of the hardest challenges to solve for. It's because you're not supposed to just build a blind system where agents can do some work, but you never understand what exactly happened, where there's one hyperparameter tune that led to 100 other tunes, and that's how you got the result. Instead, you do need some visibility into the logic and reasoning here that's happening. Now that's tough. And that's what we're improving the UI for. We have a social media style feed where agents write posts about the different ideas they had, and they will show visuals sometimes and reference papers that they found are cool so that you can keep track of things. Each experiment gets their own visual graph of, hey, how the different steps of each experiment were so that you
Mhm.
can visually understand things. So yeah, that's the first thing, is you need visibility into the work. Second, you need to be able to nudge the agent properly during the right times. So that's what we're also working on improving. Right now, the only way to do that is you will write to your own Claude Code or Codex instance in the traditional input that you already do and already use and are already comfortable with. You'll just tell your agent, hey, next experiment, you should not do that. You should do this way. Or like, largely speaking, we want this question answered over the next 5 experiments. So let's set up something properly to be able to verify this hunch that I have. You will write it in Claude Code. But at the same time, so right now the UI is read only. You don't interact with the UI to give instructions. You give instructions to your agents directly. But we're looking forward to, the next steps of iteration of this, where we will think about different ways of nudging agents. We already have some ideas like liking social media posts and stuff like that,
Mhm.
but those are a little more experimental than production.
What are like the like before like in scientific research you have checkpoints where like you publish a paper that's like a
Yeah.
checkpoint like we reached that point now we publish it and other people
Mhm.
can build on top of that checkpoint more reliably as a result like what are the checkpoints like smaller now because the AI research has more audit trail so you can publish more frequently and then other people can build on top of it more frequently as a result.
Yeah, really good point. And one of the things that you like worth mentioning here is when you publish a research paper in machine learning, about 70 to 80% of them are not reproducible. If you take a random paper and you say, hey, I want to make sure that I can get the same results, there's not enough information in the paper, or GitHub is just doesn't have stuff up to date. That's the common trouble here. But here, because everything is reproducible and easy, like every experiment is logged, everything is like saved, so you can easily reproduce them. That's one of the biggest benefits is, hey, if you see something worked, your path towards publishing is so much faster. You get all the evidence trail. You already have that data right there. You have evidence, you have like also reasoning steps of how you got there. You don't just have, hey, experiment results in a CSV file, but you also have, hey, what was the reason we got to that idea? That is what this enables. So yeah, you're right that with this data, paper publishing should become much easier. It should still be the human taste of how to write up the paper to make it the most interesting and readable to the scientists,
Hmm.
but having that evidence already saved for you to just plug and give your agent access to that data and say, hey, use all this data to like give me the method section that you can then refine, for example, is going to be so much faster.
Yeah, that makes sense.
And
Oh,
your
so
GitHub will
how'd
be
you come
right.
up with this problem to solve? Like, what makes you a good candidate to solve this problem?
Um, honestly, the fact that I'm an engineer first and not a research scientist. My background was in computer science and economics, and I really love building stuff and engineering things. So that's why I was interested in the process of research and where are the links in that process that we can automate or just make better. First, we tried solving scientific research as a whole using AI systems. That was last year, and it was a fun experiment to see how to combine ideas from different research directions to solve a new problem. But then we said, okay, where can we actually make a difference? And that was in machine learning research, machine learning and AI research. So after talking to scientists and understanding the process, we came up with the sim-autonomous research process, and it actually picked up some traffic from Andrei Karpathy when he published auto research stuff. So people got to know this kind of space and understood that LLMs are good for this autonomous research flows. But there's still a very big gap of how do you do research that is visible and understandable, and that's what we fill.